This video is designed to show the students the concept of torque. This is just a cheap broomstick. What I've done is actually cut it here at the center of mass and just put a piece of pipe inside the handle so that it can just be clipped back together like that. There's two parts to this demonstration. The first part is you get the broom and just balance it on the hands like that. And you ask the students what's going to happen if you move your left hand. And of course, if you move your left hand slowly like this, most students will think that eventually it'll topple in a clockwise direction. But the result is quite curious because you get to a certain stage and then the broom starts to slide on your other hand. And eventually, it doesn't matter which hand you move, your hands will meet at the balance point. So this is obviously the center of mass of the ruler. You can do it the other way around. You can move the right hand and it just slides on the left hand, on my left hand, until it'll stick there, and then it'll slide on the right hand. And you can explain to students in terms of the friction between the hand and the broomstick, depending on the size of the force between the broomstick and your hand. So this one here, this hand has got less force acting on it, and so the friction force is smaller, so that one will slide, that one will stick. So they'll always meet at the center of mass, and of course you can do this for any object. The second part of the demonstration is we say to the students, if we balance it at the center of mass, and I ask the students, if you chop it at that position there, and then weigh the two different sides of the broom, which one will be more massive? And of course most students will say, because it's balanced, these are going to be the same mass. So you can then break it at that position there, put it on a kitchen scale, and that's reading just under 200 grams. So once again, you can just check with the students. You can say, you're sure they're going to be the same mass? Pop that on, and that's about 350 grams. And the point of the whole demonstration is to show that if it's balanced, it's not just the forces that are balanced, the torques are also balanced. If the torques are balanced, the torque on this side of the pivot must be the same as the torque on this side, but this side the mass is distributed further away from the pivot.